Hi, I'm Jim Anderton, Director of Content at Engineering.com, and I'm here at the Stratasys booth with Charles Evans. He's an application engineer with Stratasys. And Charles, we're hearing about how disruptive 3D printing is, and we see a lot of examples of exotic-looking models of things that are 3D printed, but there are real manufacturing applications to 3D printing.
Yeah, absolutely. We've got several different kinds of applications that we see being used day to day in the industry. We've got some examples right here, something such as injection molding. We're actually printing injection molded tools, and we're using those to shoot injection molded parts into. It's nothing as rugged as an aluminum or a steel tool, but especially up front, the design is a lot easier to do. It's a lot cheaper. You can do it overnight. The innovation is really there. We've got some other things like jigs and fixturing. Something like this we can use on a CMM. You can take this end-use part, we throw it in the fixture, and you can do that kind of measurement very, very easily and very, very quickly. You can make a part like this. It's customizable. It's easy to print overnight. Something you can do very quickly. This is an end-of-arm robotic tool. So this was originally an aluminum tool that they used to do a vacuum plate kind of technology. We took this part, we integrated the vacuum tubing right into the part, and they're actually using this on their robots today.
Now, Charles, I understand that it's one argument by skeptics of 3D printing, of course, is, well, the materials aren't durable enough.
Sure.
We're looking here at something where even a short-run injection molded part, that requires a fairly high-temperature resin. What sorts of materials can you use?
It's a lot of the lower temperature, lower pressure materials for the most part. We're not going to be getting 10,000 shots out of these. Sure. It's going to be more on the 10 to 150 kind of a shot. It depends on the complexity of the part, the size of the part. There's a lot of options that go into that, but in general, it's the lower temperature materials.
And approximately how long would it take, for example, to do something like this prototype mold?
Something like this will print overnight. Maybe 8 or 10 hours. You can go in and do your design changes the next day, shoot some parts, see what it looks like, and have another one ready to go right away overnight.
Now, historically, fixturing, jigs, fixtures, a major aspect of manufacturing engineering. It might be 100 jigs or fixtures to make a simple part, a typical production line process. Can you use the same kind of overnight kind of change practice that you're talking about with the mold, with jigs and fixturing?
You're absolutely able to. A lot of the times we're replacing something that exists already, so that design is there. It's just the ability to create it quickly and cheaply that they're looking for.
Now, does it take a great deal of training for an engineering technologist to learn how to use the system?
Both yes and no. It's very easy to use the system. It's essentially a drop-in of file. As long as you have a CAD file, you can create a part. And now, on the flip side, you can do a lot of customization with that. There's a lot you can get into. That initial part creation can be very easy, and you can really go through a refinement process to get something that really works better for your process.
Charles, in the future, can we see a time when 3D printing basically takes manufacturing, fixturing, and holding, for example, completely takes over?
No, it's really more working alongside. It's a complementary technology. There are certain things in the machining world and the injection molding world that you're just not going to be able to do with 3D printing. It's never going to be as fast, and the high volume is never going to be there. But it is certainly something that's complementary for all of that, doing that prototyping work, that upfront work, the customization. What we really call it is the high mix, low volume.
High mix, low volume, that's the watch for manufacturing innovation through 3D printing with Stratasys.